Thank you, Om. Thank you, Mahendra. Thank you, Ashwini. Now, McAfee and Inspira are our event gold partners, and you can learn more about their product portfolio and also about our other event partners in our virtual stalls. Now, you can visit the booths, engage with domain experts, gather information about emerging tech solutions, and well, fill in the feedback form, and we've got some great giveaways as well. On that note, a quick thank you to all those of you who have filled up the forms and the winners as well. You can drop by there as you next listen to a fascinating story about a business that has transformed itself on the cloud. Please welcome the young CEO and co-founder of ImageKit, Rahul Nanwani.
Yeah, thank you so much, Ashwin. It's great to be a part of this summit. And what we're going to talk about today is that how do we use AWS Cloud at ImageKit, and how are we using it to add value to our customers? How are we making things simpler for them, and at the same time, making sure that our costs, let's say when we are using the cloud, they remain under control, right? During this presentation, I'd walk you through some overview about how ImageKit is set up, what is it that we do, which would basically, we would first set up some context about what does ImageKit do. Then we would dive deeper into how our infrastructure is structured and why did we get to that particular kind of infrastructure, and maybe look at some learnings from there about about how do we control cloud costs, how do we build in redundancy, how do we control latency, when delivering this product to customers globally, right? So to set up some context first, ImageKit is a cloud-based SaaS platform. What we do is we transform media in real time, right? So images and videos on a website. How do we convert it, let's say, for different browsers? How do we optimize them for different formats, different compression levels, different dimensions? So we do this in real time, right? So imagine you would have a large original image, a few MBs in size. How do we bring this down to a size that can be delivered on the web, which would be ideally be a few KBs? So that's what we do for our customers, right? So when we are doing this, there are three parts of the process, right? When we're optimizing images and videos, which we need to do, right? So there's one part where we need to get the original file, right? The second part is we need to process the file. And the third part is that we need to deliver the file to the user, right? And because we are a real-time solution, it goes without saying that when we are delivering these files to our end customers, the most important metric that we need to optimize for is that how quickly can we deliver the file, right? What's our time to process an original file right from the beginning, starting with a huge, let's say 2 MB, 4 MB kind of a file. How quickly can we deliver it to the customer after optimizing it in real time, right? So the three parts of this entire process that we need to solve for. And eventually we need to get all of this under maybe 200 milliseconds, right? The average processing times for a completely fresh image that we see on our cloud right now is 150 milliseconds, whereas we would be able to deliver 98% images in less than 50 milliseconds, right? So how do we process all of this in milliseconds? We'll break it down into three parts, and we will walk through different things that we have done to optimize each of these three parts, and we'll get to some learnings that can be applied to any business in general, right? So the first part that we have to optimize is that what's the time taken for us to get the original image or the original video, right? Now there are two parts where the original file could have been stored, right? One is that we provide an integrated storage that comes with ImageKit. So your file could be there in that integrated storage, or we also provide an option to integrate with the customer's cloud storage, right? We have to basically optimize the time that it takes for us to get the file from both of these locations, from our integrated storage as well as the customer's cloud storage. Now, one key factor when we are, let's say, looking at latency, and this applies to any business, is that you need to reduce the geographical distance between where the file is being accessed from and where is the original location of the file, right? So for example, if you are a business delivering, if you're a business catering to audience in India, your servers ideally would be in India because you're trying to minimize the geographical distance between your end users and your servers, right? So we had to do the same thing, that we have to reduce the distance, the geographical distance between the original image storage and our servers where we would finally be processing those images, right? So when it comes to the integrated storage, obviously that's under our control, right? So we can locate it anywhere we want to. So we decided to build that storage on top of AWS S3. It's highly reliable. It guarantees high availability and SLAs. It's almost like infinite in scale, and it is available in multiple geographical locations globally. So when ImageKit first started, we started off with a storage and a processing region in Singapore, right? And because the location of this integrated storage is under our control, we sort of kept it in the same region as the processing servers, right? So imagine the processing servers are EC2 servers in Singapore, AWS Singapore, and the integrated storage or the media library is what we call it in ImageKit is in Singapore as well, right? Given that both of these things are in the same cloud, both of them are in AWS, both of them are located in the same location, which is Singapore, the time that it takes to access the original image, if it is there in our integrated storage, is usually in single digit milliseconds, right? The network connections on the cloud, right? So when you are accessing two services in the same region, they could be in different availability zones as well. But then if you're accessing two services in the same cloud, in the same region, your access times would always be in single digit milliseconds. So that's what we took advantage of when we were building our integrated storage, that we co-located them with our processing servers, right? And so this is how, let's say, a single region looks like. So there is a cluster of servers that would actually be processing the media. And then there is a co-located media storage. This is the integrated storage that ImageKit has. It's built on top of AWS S3, and it is in the same AWS region, right? So the combination of this forms one processing region in ImageKit, right? So processing region is basically processing servers plus media storage, right? Now, when we built this processing region, the first one, like I mentioned, the first one that we built was in Singapore. So when we this triangle that you see on my screen is basically the first processing region that we built. Now we have already solved the problem for access of original image from integrated storage. That's already down to single digit milliseconds. For even for customers that are geographically close to Singapore, for example, customers who are there in Malaysia, maybe they have their servers in Malaysia, or let's say someone having their servers in Indonesia. All of these countries are geographically close to Singapore, right? So it may not, let's say, the second part that I mentioned, that we also need to minimize the time it takes for us to access images from the customer storage. So by having this region in Singapore, we were able to minimize the time for customers who had their servers or original images in these countries that were around Singapore, right? So it would still take us longer to access the image compared to what it took, let's say, with the integrated storage, right? So for the integrated storage, we were able to access it in a few milliseconds. For anything that's outside of our cloud, it's still, let's say, geographically slightly far away from Singapore. It would probably take us double digit milliseconds to us, but then it is still acceptable, right? That if you're able to, let's say, download all of these images in 30, 40 milliseconds, it's still acceptable. We still have some headway when it comes to headroom, sorry, when it comes to processing the image, right? Later on, right? So this processing region in Singapore helped us in minimizing the time it took for us to download original content for users who had their servers in the neighboring countries, right? But then we ran into a problem very soon, right? As we were scaling up in 2017, we got our first customer who was based out of Europe. They had their storage in Germany, right? Which is basically the yellow color dot that you see on my screen. And we had only one server, which was in Singapore, right? Now, geographically, these are very far away, right? And regardless of what network you access it on, whether it's a cloud network, whether it's public server, public internet, whatever you use, more the geographical distance, more of the time it takes for us to download the image, right? And the same thing happened with us when we started accessing the customer storage, which was in Germany. It would easily take us more than 200, 250 milliseconds just to download the image. Now we are looking to deliver the final image in under, let's say, 200 milliseconds. But then just to get the original image, we were spending easily more than 250 milliseconds just to get the image from Europe to Singapore to process it, right? So that brought us to the next evolution in our infrastructure, that we need to be geographically close to all customer storages, right? Now, it is obviously impossible to locate ourselves in all possible cloud locations that are there globally, right? So there are probably like 25, 30 different cloud locations that exist globally, major ones that exist globally right now. So instead, what we did was we slowly evolved our infrastructure, and instead of spreading ourselves around in all of those cloud locations, we found out major centers where we should be located, right? And again, this can change over a period of time, but then given where most of the companies or where most of the business is happening, where most of the companies have their cloud locations, we decided to spread out our cloud locations as well in those regions, right? So starting from the right, we have a cloud location in Sydney, then in Singapore, Mumbai, Frankfurt in Europe, then one on the US East Coast and one on the US West Coast, right? Having this kind of a distribution for our network, we were basically able to cater to a large set of audience in all of these countries. We are able to minimize the time for access in all of these countries. And the way we built our system was that we built our routing in a way that we could route a customer to any particular region, regardless of where they were coming from. We made it basically really simple in our infrastructure to route a customer to a specific region, so that depending on their use case, if we have to minimize their latency, we can do that, right? So by doing this, earlier our access times from Singapore to EU, they were more than 200 milliseconds. By setting up our processing region EU in Frankfurt, we were basically able to bring down the latency to less than 50 milliseconds for any country in Europe, right? So we are basically able to cover the entire European Union region, bring down the latency to download content from any original storage in that region by having a processing region in Frankfurt, right? So that was one obvious advantage, that we were able to bring down latency. The second advantage that we have been able to build, and it's something that's critical for all businesses, is to build in redundancy in the system, right? Now, though it's a very rare scenario that AWS Singapore would stop working, but then it can still happen that your servers for some reason stop working, right, within a region. Now all of the regions that ImageKit has are absolutely identical to each other. So the setup that we have running in Singapore is identical to what we have in Europe or in the US. So each of our regions can act as a fallback to each other. We make use of DNS health checks, CloudWatch alarms, and Route 53 to basically substitute one region for the other in a rare scenario where, let's say, AWS Singapore, whatever setup we have in AWS Singapore, it goes down, or AWS itself goes down in that region, then we would basically be able to route our traffic to from a completely different region as well. Yes, it would increase our latency, but then at least our service would keep running for our customers, right? The next advantage, which we realized in fact a lot later, was that it helped our customers to fulfill their compliance requirements, right? So there is a requirement in Europe that any data that you process for your European customers should remain inside EU boundaries, right? So any country in Europe would expect their data to be processed in EU as well, and that's what our servers in Frankfurt help them achieve. Similarly, in India, there is a regulation that anything that's financially sensitive or personally identifiable should remain in India. It's a recent regulation, and because of our processing region in India, customers who use ImageKit are able to comply with this requirement, right? An additional benefit to our customers is that it's not only helping them reduce the latency for the final image that they're accessing, it also helps them in saving costs, right? So there is a data transfer cost involved if you're transferring from S3 to some other service. But then if that other service, which is EC2 in this case, if it is in the same region, then the cost is zero, right? So imagine if our customers have their storages in AWS Mumbai, or they have the servers running in AWS Mumbai. For them to use ImageKit, their cost of that data transfer is zero, right? Now, thinking of it from a customer's perspective, even before using ImageKit, they would not have been paying any cost. Let's say if they had their S3 bucket attached to CloudFront, would not have been paying that data transfer cost. Had ImageKit not placed its servers in multiple regions across the globe, they would have had to pay that cost, right? So by spreading our servers in these key cloud locations, we have been able to help our customers in reducing their costs as well, right? Uh, things that you need to watch out for, let's say if you ever try to set up something that's spread across the globe, that you need to watch out for what are the data transfer costs between different processing regions, because invariably there is data flowing between Singapore to Europe to Frankfurt, you need to control those costs. It should be easy to route from one region to the other. You need to make sure that each region is secure, that you do not leave open ports or open services running just so that you can access something from Singapore while in Europe. So you need to keep your security in check. Otherwise, one of your processing regions could be subject to any kind of attack. And not all services can be or should be run distributed across all regions, right? So it would make sense to have your database probably running in a central location, and there are different ways to mitigate, let's say, any threat to your database instead of spreading it globally. So there are some services that even we run that are running in a single region. So you should take a look at your application, and if it makes sense to distribute it globally, then you should go ahead for it. Yep. And for the final delivery, when we have to deliver the image in just a few milliseconds, we leverage AWS CloudFront. You should always use a CDN to deliver your content, even if you're delivering it in a single country, because CDNs have a very wide network. They have pairing with ISPs that allow them to deliver content in a few milliseconds. They would also help you secure your systems and reduce the workload on the processing servers, right? So CDNs will keep delivering the cache content, whereas your processing systems can work on processing the new images or the new data, right? So this is what our final infrastructure looks like, with the blue dots indicating the CDN nodes globally, the circles and the triangles indicating where our processing regions are located globally, right? The end result is that we are able to deliver a service for close to 99.99% uptime, which is less than 5 minutes of monthly downtime. We are able to serve 98% images in less than 50 milliseconds, and we have been able to reduce costs and latency for our customers. Yeah, that's it. I hope that this would help you. This would give you some ideas about how you would, let's say, structure your application if you're serving a global audience, and what are maybe some things that you should consider when building such an application. That's it. Thank you.